All right, this is Mr. Gillum, and today we're going to talk about scale drawings again, and we're actually looking into some area and perimeter. So what you're going to find is there's some relationships between the scale factor, the area, and the perimeter, and it's going to help you to solve some of these problems a little quicker and more efficiently. It says the ratio of the perimeter is equal to the scale factor, and the ratio of the area is equal to the square of the scale factor. So I want to point out that these are two different things when you're talking about perimeter and when you're talking about area. Perimeter and area, they're two different things. One is you square it, one is you just use it. It's equivalent to. Okay, so there's two different things going on here. And I'm going to explain that again some more here as we go through the notes, but for now, that's just something to keep in mind. The perimeter is equal to the scale factor, increases the same rate, but the area, on the other hand, increases at the rate of its square. So, like I said, I'm going to cover that in a little more detail here in a second, but I want to just remind everybody, just in case we need to square some fractions, how it works. When I have an exponent to the second power, like 3 squared, I know that's 3 times 3, which is 9. But if I had a fraction like 3/4 squared, it might be tricky for me to understand how it works. Well, think of it the same way. 3/4 times 3/4 would be 9 over 16. But really, if I wanted to just bypass this, I know that 3 squared is 9, and I know that 3/4 squared is 9/16 because 3 squared is 9 and 4 squared is 16. Okay, so I just want to kind of show you and introduce you to how this exponent works with the fractions. 1/5 squared would be like 1 squared is 1 and 5 squared is 25. And if I had like 2/10 squared, I would first, of course, let's change it to 2/11. If I had 2 squared, it would be 4, 11 squared, 121. So when I square a fraction, I just square the top number and the bottom number. So that's just something to keep in mind. Might help your homework go a little quicker. Let's take a look here. It says the area and perimeter. We have a scale drawing below showing an enlarged computer chip. So this is bigger than the actual computer chip itself. We measured each side of the scale drawing. The square chip is 4 centimeters. Okay, well, on the drawing, it's 4 centimeters on each side, so that's going to be important. I'm going to go ahead and write that information in, 4 centimeters on each side. And I notice that we have a scale here, okay? Not a scale factor, just a scale for now. It says, what's the perimeter of the drawing? So I'm looking at the drawing right now. This is the one that we're looking at. Perimeter, we've done this before. We just added the lengths of each side. So 4 plus 4 plus 4 plus 4. 4 plus 4 plus 4 plus 4. That would equal 16. So I know the perimeter is 16 centimeters. It's not so bad, right? The perimeter of the actual chip. Now remember, the actual chip's smaller. So before we can actually find the perimeter of the actual chip, we need to have a scale factor. And so right now we have a scale that says 1 centimeter for every 2 millimeters. So now actually what we're going to do is, I know there's 10 millimeters in a centimeter, so I need to divide 2 by 10. 2 divided by 10. That equals 2/10, or 1/5. Or in this case, we might even want to use a decimal. 1/5 is the same as 0.2 when I divide 1 by 5. So what I'm going to say is 1 centimeter, and in this instance, I'm going to go ahead and use a decimal, equals 0.2 millimeters. Or centimeters, sorry. Every 1 centimeter on our drawing is worth 0.2 centimeters in real life. Now this is where the new information about the scale factor comes in handy. If I know the perimeter of the scale drawing is 16 centimeters, I know that the perimeter of the actual chip is 0.2 that amount. So all I'm going to do is I'm going to take 16 times 0.2, or 16 times 1/5. Either way you want to think about it. When I take 16 times 0.2, I get 3.8. So I know the perimeter of the actual chip would equal 3.8 centimeters. Okay, it's actually 1/5 of the drawing. Okay, what's the area of the drawing? So now I'm looking at the area of the actual drawing again here. So 4 by 4 by 4 by 4. So I know length times width, 4 times 4 is the area. In this case, it would be 16 centimeters squared, or square centimeters, I should say. Okay, now the area of the actual chip has a different relationship than the perimeter. I can't just multiply this scale factor here by 16 and get my area like I did with perimeter. They have different relationships. Okay, so for perimeter, multiply by the scale factor. For area, we're going to square the scale factor and then multiply. Oops, wrong way. We're going to multiply by the scale factor after we square it. Okay, so for the area, we're going to actually have to take 16 times that 0.2 squared. Okay, that 0.2 squared. So we're going to take 16 times 0.04. And 16 times 0.04 is 0.64. So the area is much smaller than, and I need to label that centimeters squared, than the drawing. Remember, this drawing is bigger than the actual computer chip, so it should be getting smaller by quite a bit. Okay, so that was only the first example. We need to do a few more, I think, until we get good at these. Again, we have a scale drawing here of a miniature glass mosaic that helps you see the detailing on the tile. Okay, so obviously this is a bigger picture than what the other one, what the actual tile would be. Okay, and it shows me that 4 centimeters, 4 centimeters, each side is 4 centimeters. Since it's a square, we can just write that on all of them if you would like. And it says, what are the perimeter and area of the scale drawing? Well, this is the drawing itself, so let's go ahead and find the perimeter and area. The perimeter is the sum of all the sides. So again, we have 4 plus 4 plus 4 plus 4. So again, we have 16 centimeters. The area is length times width. So length 4 times width 4, 16 square centimeters. We abbreviate that centimeters squared. So that should be a piece of cake for everybody. We know how to find area and perimeter. First part's all done. Second part's the tricky part. The perimeter, I need to multiply by the scale factor. The area, I need to multiply by the scale factor squared. And that has to do with also how we label our units. It's a good way to remember. And perimeter is just distances. Area, it's the amount squared. So for the perimeter, before I do anything, I need to know what the scale factor is. And the scale factor has the same units. So again, I should get a decimal here because I know this scale drawing is bigger than the actual tile itself. So if I have 1 centimeter comparing to 4 millimeters, the scale factor, if I know that there's 10 centimeters in every millimeter, then I know I would have to do 4 divided by 10, which equals 0.4. So really I know that every 1 centimeter is 0.4 centimeters in real life. This is still going to be the model compared to the actual or the original, however you want to say it. Okay, so that means yesterday we learned about if it's a 3 down here, it's 3 times as big, 4 down here, 4 times as big. Well, now we have 0.4, so it's 0.4 times as big as the drawing. So that would make sense. It's smaller than the actual scale drawing. So now I'm just going to multiply this since I know that the scale drawing is 0.4 times as big as the actual model here. I'm going to go ahead and multiply the perimeter that I know, 16 times 0.4. It's 4.4 times as big. So 16 times 0.4 in this case is going to be 6.4, and we're going to have centimeters. Okay, so easy enough. You just find the scale factor over here, and you multiply it by the perimeter. On the area, we're actually going to multiply by the scale factor squared. So I need to know what 0.4 times 0.4 is. That's 0.16, okay? In this case, that would be 0.4 times 0.4, which is 0.16. So I'm going to take my area that I know, which is 16 centimeters squared, and I'm going to multiply it by the scale factor that squared, 0.16. All right, so in this case, I know that's 2.56 centimeters squared. Okay, 16 times 16 is 256. And I move the decimal place. All right, so it's a little complicated today. There's a lot of steps to it. what is the actual perimeter and area of the master bedroom in the blueprint shown below? Okay, well, before we can do that, we need to know how much the area and perimeter are in the actual blueprint. So let's take a look here. It says 1.5 inches and all this stuff. Okay, so looking at the master bedroom here, it's just this little corner. All right, just this little corner of stuff. Actual and area perimeter of the master bedroom. Yep, so we're just looking at the master bedroom. So this is the scale, and obviously this is smaller than the actual thing. Let's go ahead and get our scale factor right now. Right now it's 1/4 inches equals 3 feet. I really think it would be easier if we decided that how much 1 inch is equal to. We'll multiply both sides by 4. I just don't like working with those fractions. I know that 1 inch is equal to 12 feet. Okay, that's going to be important for me here in a second. So unfortunately my scale is now 1 inch equals 12 feet, but my scale factor is not good yet. 1 inch compared to 12 feet. So I need to change feet into inches too so that they match for my scale factor. So 1 inch would be like 144 feet. 1 over 144. This is my scale factor. All right, it's 1 to 144. So let's start with finding the perimeter of the drawing. Perimeter of drawing, or model, you could say. Well, I know it's 1 inch here, 1 inch here, 3/4 inch and 3/4 inch. So let's just add them all up. 1 inch plus 1 inch plus 3/4 inch plus 3/4 inch. So I have 2 inches plus 6/4 of an inch, which would equal 1.5 inches. So 2 inches plus 1.5 inches would equal 3.5 inches. Okay, so that's the perimeter of the scale drawing. The area of scale drawing, or just say drawing, we could just say the drawing, is length times width. So 1 times 3/4. 1 times 3/4. Well, anything times 1 is itself, so we're going to say 3/4 inches squared. Okay, so now that's just the footwork I have to do. I need a scale factor. I need to know what the perimeter is right now, what the area is right now. I need all these things before I can find the perimeter and area of the actual room. Okay, the perimeter is not so bad. I take the perimeter of the drawing and I multiply it by the scale factor. And so I say, oh, sorry, not 1 over 144. The scale factor is telling me that the actual thing is 44 times as big, 144 times as big. So I'm actually going to multiply it by 144. So we're going to say 7/2 times 144 over 1. 72 times 7. 504. Okay, 504 inches. We're going to probably need to change that to feet in a minute, but for now, it's 504 inches all the way around because our scale factor is in inches. And for the area, I actually need to do a little more work since I know that 144 is it's 44 times as big. I need to square that 144. So I need to take this 3/4, oops, not 3/14. I need to take this 3/4 times 144 squared. Now, there's a couple ways I could do this. I'm just going to write, instead of finding that huge number, I'm going to say 3/4 times 144 over 1 times 144 over 1. I'm just going to do it twice that way, and then I'm going to reduce a little bit. 72, 136. So I'm going to take 3 times 36, which is 108, times 144. Oh my goodness, that would be a big problem to do. You know, we might have to actually adapt some calculator usage today. So let's go ahead and look at our calculator and see what that gives us. Oh, I take the whole hour just doing calculations. Let's see here. I don't even know where to find the calculator on this thing. I'll just have to use the one on that I got right here in front of me. 108 times 144 equals 15552 inches squared. All right, so these can be a little tricky, and I think that was it. Oh, we got one more. We'll have to do this one in class. So that's all for tonight.